Algebras. Welcome to Chapter 6, Lesson 1. Before we start Lesson 1, let's go through a quick overview of all of Chapter 6. So we're going to start talking about polynomials in Chapter 6. And what that will do is that will lead us further into a chapter for Chapter 7 we call factoring, which will lead us into being able to solve quadratic equations. So prior to Algebra 1, you've only dealt with solving linear equations and inequalities. Now we're going to get into solving equations that have an x squared involved. Before we can do that, we have to remember some of our previous work with polynomials or terms. Okay, so today I'm going to talk about classifying polynomials. I'm going to go through vocabulary, and that's going to be it. You're just going to have to identify certain pieces or put your polynomials in standard form. Then what we're going to do is we're going to learn how to add and subtract polynomials. That's combine like terms. Okay. We're going to talk about your exponents rules in lesson 3. Then we'll stop and review it all to have our quiz. Then what we're going to do is learn how to multiply binomials and trinomials. That piece is important. The special case stuff, not quite as important, but it is kind of cool to see the patterns that emerge when we start multiplying binomials together. And there are some special patterns that will help when we go into Chapter 7 to factor. There is a polynomials regents review in this booklet, and then an exam review and exam. Okay? So let's begin with our vocab in classifying polynomials. And lots of vocabulary terms here. A term is a multiplied piece. It is your specific piece of a polynomial. Okay? So a term is a number, variable, or multiplied number and variable combo. Like terms have the same variable raised to the same power. And a power, of course, is that exponent. A coefficient is the number in front of variables in a term. So the coefficient is that number out front. A constant is just a number. A monomial is a single term. Binomials are two terms linked by adding or subtracting a plus or a minus sign. So I have a feeling you can probably guess what trinomials are. Binomials are two terms linked by your plus or minus sign. Trinomials are three terms linked by plus or minus signs. A polynomial is the general word for a term or multiple terms linked by plus or minus signs. Now, the degree of a polynomial is one of the things we're going to discuss and study, and that is the number of the highest degreed term. The leading coefficient is the constant in front of the first term in standard form. And standard form is another thing we're going to study specifically here. And that would be descending exponential term order. So if there's multiple exponents with multiple variables, it gets a little dicey for standard form. It gets a little more difficult. But standard form is typically very general as far as it's descending exponential order, starting with the highest exponent term and then getting down from there. So obviously, these are all very new and we need to study them. You may need to pause right here to continue writing some of these vocabulary terms because I'm trying not to take a ton of time with your video, but I'm also like rambling right here so that you can keep writing some of your definitions if you need to. Pause here, finish writing your definitions. Okay, let's talk about the degrees of a polynomial. So the degree of a term is the value of the highest exponent in the term. So for example, this polynomial is in standard form because it starts with its highest degreed term and then the next degreed term and then the last degreed term. And it's a fourth degree polynomial because the exponent on the highest term or the first term is 4. If there are multiple variables in a term, you add the values of all the present exponents in that term to figure out its degree. So this is a 9th degree term. This is a 9th degree polynomial, and it's a 9th degree term, and here's why. 5 plus 3 plus 1 is 9. This term is a 4th degree term right here, but the polynomial is still a 9th degree polynomial because the highest present term is 9. That would also be the first one because of that, okay? This polynomial would need to be placed into standard form. This would have to go first, this 5th degree term right here. 2 plus 1 plus 2 is 5. That's how I figure out its degree. Stop and look at that picture if you need a little bit of time on how to figure out the degree of a term. There's a 4th degree term. This is a 9th degree term because the degree of the highest term is 9. Okay, so let's do some. The degree of this is 4. The degree of this is 2. It's the exponent present, right? The degree of this is 1. The exponent present is 1. The degree of 5, there is no variable present, is 0. It's a 0th degree when you have a constant, when you only have a constant, okay? Now, the degree of this term is 6 because 4 plus 2 is 6. The degree of this term is also 6. 2 plus 1 is 3, plus 3 more is 6. Just look at that. They're both 6th degree. They're both 6th degree term. Now, here, these are not the same term. These are actually unlike terms, which will be one of the things we talk about. Because these are separate unlike terms who both have a highest degree of 2, this is a 2nd degree polynomial. Over here, this is a 4th degree polynomial because each of these are separate terms and the term with the biggest degree is 4, so the whole polynomial is a 4th degree polynomial. 2nd degree, 3rd degree, 0th degree. It's named by the biggest degree, so it's a 3rd degree polynomial. 3rd degree, 0th degree. 4th degree, 2nd degree. What was the highest of all of them? 4. The whole polynomial is determined by the highest degree of the highest degreed term. Let that sink in, right? Now, the leading coefficient is just the number in front of the highest degree term of your polynomial. Okay, so in this example right here, the highest degree term was right here. The leading coefficient of it is -6. That's it. That's how you find it. So typically we like to put things in standard form for that reason. So then you can just say, oh, it's the first number in the term, right? It's the first number in the whole polynomial. That's the leading coefficient. So here, the leading coefficient is 3. Here, look at all your terms. This is a higher degree term. The leading coefficient is -1. Yes, the sign goes with. I already answered this one, but that was purposeful. I knew it was down here as an example. -6 is the leading coefficient because this is the highest degree term right here. So highest degree term. The number in front of the highest degree term, the coefficient in front, is called the leading coefficient. Standard form just means rewrite in descending exponential order. So if there's only one variable involved in all of your terms, you just put them in order, biggest, then next, then next, then next, smallest. If you think about it, x to the 0 power is equal to 1. Okay, because anything to the 0 power is 1. That just means that if your variable has a 0th power, you only have a constant left. And what that means is the last term in standard form will be the constant term. Okay, that's what that will mean when we look at these. So let's look at some examples and get some things in standard form here. Okay, if there are multiple variables in the terms, the variables are to be written in alphabetical order and the terms are in descending degree order. Okay, that doesn't happen a lot. It honestly only really happens in this lesson so we can learn how to put things in standard form. Usually we're only dealing with one variable at a time in our polynomials, but these are where we start to learn that, right? So this is in standard form. Determine whether the polynomials are in standard form, and if not, rewrite them in standard form. So here we are, standard form. Descending exponential order. It started with the largest exponent present and then deteriorated from there or decreased in order from there. B is not in standard form, so let's put it in standard form starting with the term with the highest exponent, and that would be 5x cubed. So that's going to go first. Now the next lowest exponent is -6x squared. Then below that is the positive x. And then the last one is the one with the 0th degree, right? So the constant is the last term. Now it's in standard form. Oh boy. C has 2 variables involved, right? So let's figure out each of the degrees first, and then we'll put in standard form. So this is a 2nd degree right here. This is a 5th degree right here. This is a 3rd degree. This is a 4th degree. And this is a 0th degree. Okay, so now let's put them in order, starting with the 5th degree polynomial. That's this one, or excuse me, 5th degree term. And yes, this is a 5th degree polynomial. So its sign and constant go in front. Now we go to this term. So positive 7a squared b squared. Okay, now we'll go to this term, -5ab squared plus 10ab, and last, plus 3 at the end. Now you've got standard form. Okay, check over here again. So this is a 5th degree right here, 4th degree right here, 3rd degree right here. This is in standard form. When there are more than one variable involved, you go with the degree order. Notice we put our variables, when there's more than one involved, we put them in alphabetical order in the term. So this term isn't 10BA, it's 10AB. The reason we have these rules is really just to make sure that we all kind of have similar looking polynomials. And then that way it's a lot easier for us to check each other's work. Okay. Okay, so make sure you know these vocabulary words as you're going through your homework. Maybe keep this open or keep this part of the video paused right here so that you have these specific things. Use each of the sections and the examples in there to help you. These have been Regents questions, so I really do need you to make sure you understand each of the vocabulary terms because this is how I talk throughout chapter 6, throughout chapter 7, throughout chapter 8. I am going to be using these words to describe these pieces. Make sure you really have them down pat. Okay? All right, algebras, have fun. Good luck. I'll be seeing you soon for adding and subtracting our like terms. Bye, guys.